Hi everyone, this is the first video for section 1.3 on reasoning and logic. So like always, if you haven't gone and read section 1.3 in the textbook, please go and do so. As you can see just from this first example, I'm going to assume you know the definition of a statement and how to do the negation of a statement, which is on page 23, the first page of the section. Okay, so after you've read the section, we're just going to go through some examples that are a little bit different than the ones in the book, just so you can see someone work them out and kind of see that thought process. So the first example says to identify each of the following as a statement or not a statement. So remember that a statement is a sentence that is either true or false, but not both. So it has to be a sentence, a full sentence that can be objectively true or false. So the first one that we have is this statement that the figure is a circle. So if we're given a figure, we make the statement, this figure is a circle. So based on whatever figure we're given, yes, this can be objectively true or false. So this is a statement. So now, if it's a statement, we need to write the negation. So remember, negation just says to change the sentence so that it has the opposite truth value. So the negation of this is going to be with the negation, whoops, sorry about this. So the negation is this figure is not a circle. So sometimes the negation can be as simple as just putting a not into the sentence. That's all you would need to do in this case. If the figure was a circle, changing the statement to this figure is not a circle would change the truth value. Okay. B, this figure is pretty. So if you're given a figure, you are given this statement, this figure is pretty. Well, pretty tends to be something that is more subjective, right? It depends on who's looking at the figure if they think it's pretty or not. Something being pretty is an opinion. It's not a statement because statements are facts. So this is not a statement. Okay, C is 5 plus 3. So 5 plus 3 what? So remember, a statement has to be a full sentence. So in this case, this statement talks about 5 plus 3, but it doesn't tell us something about it that we can assess the truth value of. So this one is, again, not a statement because it doesn't have anything to assess as true or false. Okay, D says 5 plus 3 equals 8. So this one is a statement. And this one is a statement because we can tell if this is true or false, right? So we know, because we know how to add numbers, that 5 plus 3 actually is equal to 8. So this is a true statement. Whereas you can see part C, 5 plus 3, there was no equal to sign or anything to assess the truth value of. So part D, 5 plus 3 equals 8, that's a statement. So now we want to write the negation. So the negation of the statement is the mathematical equivalent of putting a not into the statement is 5 plus 3 does not equal 8. So that's the negation. So if 5 plus 3 equals 8 is true, 5 plus 3 does not equal 8 is false. And lastly, we have E. So this is 5 plus x equals 8. Well, this is a mathematical equation. And so this one, we don't know what the truth value is, right? So this is actually not a statement. So this is not a statement because it depends on what x is. If x equals 2, well, we know that that's false. But as we can see in the one above, if x is 3, well then yeah, 5 plus 3 is 8. So this one is not a statement because the truth value changes depending on what value x takes. Okay, So this was our example on statements and negations. So it's page 23 in the textbook. So now we're going to move on to truth tables. So truth tables are covered on page 25, and we're going to go through these examples. Okay, so we remember that truth tables will always have variables P and Q, and you're going to assess the possible truth values. So, right, P represents some part of a sentence. So P, for example, could be that I have brown hair. And Q, for example, could be I wear glasses. And we're going to assess the different truth value of these compound statements. Remember, the compound statements are and or on page 25. And so we're just going to see how these things work out. So the first example we're going to look at is P and Q. So we wrote out the word and here, but there's also different ways that you can write and. So in logic, so for this section, and is written by this little caret, and sets section, the section we're going to cover next time, and is written by this little symbol. So you can see this kind of looks like the N, and kind of looks like this symbol. So we have it this way, and or, right, this or that's right here in this other one, in logic, this or is written as the upside down caret, and in sets, it's also the same symbol, but upside down. So that's for or. So we have and or written in these different ways. So you don't have to know these symbols, but it's just something to keep in mind that if I ever use them in any of my videos, or if you see them somewhere in the textbook or on your homework, that's how we denote and or in logic. Okay, so for this first one, we need to finish filling in the truth tables. So we have the values for P given, true, true, false, false. And the value for Q, we need to fill in ourselves. So if you look at this on page 25 in the textbook, we always have the same exact setup for the P column and the Q column. So P will always be set up true, true, false, false, and Q will always be set up true, false, true, false. Right, and we set it up in this way to make sure that we get every combination of true and false that's possibly there. Right, we can have two truths at the beginning, right, in this top row. The bottom row, we have two falses, and in the middle rows are one true and one false, but we have two different ways that can happen. So we have this set up to make sure that we can account for all possibilities of P and Q being true and false and all of those combinations. Okay, so if this section, it didn't make a lot of sense to you, one thing I think that's really helpful is to just think about, when is someone lying to you? If they tell you this and this, for example, like I said earlier, if I tell you I have brown hair and I wear glasses, think about, when am I lying to you? Okay, so we're going to use that to help motivate this. So P and Q. Well, if both the things I told you were true, then that means that I was telling the truth, right? I was telling you the truth because both things I said were true. However, let's imagine that one of them was false, and I told you this and this. Well, if one of them was false, then that means that I was lying to you. So that takes care of this case. And this case, if just one of them is false, that means that I was lying. But even more so, if both of them were false, I was definitely lying to you. Okay, so this is how we fill in that truth table. So one way to remember the and is that the and is only true if both are true, right? And we can see that based off this table. The only place we have a true is in that first row. Okay, the next one. So this one has PQ, not P, and P or not Q. Sorry, Q or not P. So again, this one, we have the exact same setup every time. P is two trues and then two falses. So now Q is going to be true, false, true, false, because we want to have the exact same step every time to account for all combinations of true and false. So now this not P. So just like it shows on page 25, the negation, we just switch everything to the opposite. So if we're looking at not P, well, that means that we do the connective on P. So whenever our truth tables get kind of long, like example 6 on page 25, I think it's helpful to cover up the section so that you just look at what you need to look at. So for this column not P, all we need to look at is P, and we need to change every true to false and change every false to true. So we can do that pretty easily. So we can change every true to false and every false to true. We negate it. We make it the opposite. Okay, so now I'm going to uncover this row to see what I need to do next. Well, let me fill this back in. Okay, so now we're looking at Q or not P. So we're going to look at the columns Q and the columns not P. Right, so we're only looking at these two preceding columns, and we're going to connect them using or. So like it says at the top of page 25, or is only false if both are false. So, for example, if I'm telling you I have brown hair or I have glasses, well, only one of those needs to be true for me to not be lying to you. So if one of them is true, then I was telling you the truth. But if both of them are false, I had to be lying to you. Again, if both of them are true, I was definitely telling the truth. But I only needed to say one thing that was true for this or statement to be the truth. Okay, then we uncover what we covered up, and there is our answer. So these are these truth tables. So if covering it up confuses you, normally if I was doing this on a physical piece of paper, I would just use a pencil or a pen to cover up a row that I wasn't using, just so that I don't accidentally look at the wrong column. Okay, so these are the truth tables. So there's lots of examples of this in the book, but this is something that a lot of people struggle with. So if it doesn't make sense to you, don't feel bad. Just take some time on it. Definitely email me or come to office hours if you have questions, but this is a tough topic for a lot of people to grasp. So don't feel bad if it's confusing. Okay, so this last example on the first page is State De Morgan's laws. So these laws are really important just because they are essentially the distributive laws for logic. So it tells us how to negate these compound statements. So we're going to do not P and Q. So when we look at not P and Q, how does this work? So we essentially distribute the not to each thing. So we're going to have not P, and then we're going to negate in a way this and, but we're going to flip this and to or, and then we're going to negate Q. So we apply the not to each thing, the P and Q. And then similarly, we can do the same thing for or. So when we do not P or Q, we're going to negate the P, we're going to switch the and, we're going to switch the or to and then we're going to negate Q. So these are De Morgan's laws. I just want to make sure that you see how this works. You just distribute the not to all three things, the variable and the connection between them that's either and or. Okay, so this was statements and negation and some basic truth tables using and, or, and not. And so that is all for this video.